All right, so not all uranium can undergo nuclear fission. Okay, so there are two main isotopes of uranium. So we have uranium-235 and uranium-238. In nature, most uranium exists as uranium-238. So 99.2% abundance. Only small amount is uranium-235. Right, and only uranium-235 can do nuclear fission. Uranium-238, it can, but it just takes a lot of it's more complicated to do that. Okay, so basically what I want to say is uranium-238, which is a higher percent, much higher percent abundant, is not fissile. So we can't really use that in the nuclear power plant to make electricity. So since most of uranium is 238, so but we want uranium-235. We need to make uranium-238 undergo the process called enrichment process to make some of the uranium-238 to become uranium-235. All right, and all we need in the reactor, we only need 3 to 5% of uranium-235. Doesn't have to be as pure. Okay, and so this is inside the reactor. This reactor usually contains about 3% uranium-235, and the rest are uranium-238. Now the question is, hey, why do we use what can we do the enrichment make all 238 to 235? Because more 235, the more fission we can get, the more power, the more energy we can have, right? Well, too much of a good thing is not good. If we use too high percentage of uranium-235, it's what's it called? Too much uranium-235 could cause a runaway reaction, which means that it's uncontrollable fission. In the nuclear bomb that you saw in the previous video contain 85% uranium-235, and that's why the purpose of the weapon is to kill people, so we don't care. We just want to kill people. We want energy and power. But in this case, we want to control it to produce electricity. So we have to be able to control the nuclear fission in here. So we can use a lot, and we don't need to use a lot of uranium-235. Okay, and the much high percentage of uranium-238 serve two purposes. Okay, here's the reason why we use a lot of uranium-238, which is non-fissile reactant. So one, uranium-238 can absorb some neutron from uranium-235 and preventing runaway reaction. So uranium-238 absorbs the neutron, and it breaks down to neptunium, which can break down further to plutonium-239. Okay, so it helps us control the extent of fission reaction. And two, the plutonium-239 can also undergo the nuclear fission. So basically, we can use plutonium to do nuclear fission later. So not like we just uranium-238 just go to waste, doesn't do anything. Well, actually, it becomes plutonium-239, and plutonium-239 can also act as a uranium-235 as well. Okay. All right. So that is the fissile material. Now we're going to talk about how do we control the this dangerous reaction. Okay.